Okay, so today we're going to talk about curve sketching, and in this lesson we're going to talk about when they give you a graph and you have to find the derivative, and you have to graph the derivative of that, and you have to graph the normal function or the antiderivative graph. Okay, so we're going to look at the derivative of the before graph that we had. And our before graph was a parabola, so there are 3 steps that we need to use, and the maxima and minima are the x-intercepts of the derivative, so that's a rule of thumb, and estimate a couple other points and connect the dots. So we gotta first realize what the derivative graph will be. So from a parabola, which is which has the squared, so we will obviously get a line here, and this is an approximation graph, so our lines don't have to be exact, but our negative and positive part should be like, is the slope going to be positive or negative in a place. So our minima in this graph was 0, 0, so we're gonna have an x-intercept at 0, as you can see, and then we just have to connect a couple other dots, just draw a line. Keep in mind, like, if it was an x squared graph, then we would get the graph of 2x, so we would have a positive slope, obviously. So that's our function here. So now we're going to look at the harder one. We were given the graph of f prime of x. Now we have to find the graph of f of x. So first thing we need to do is find where the graph is increasing and decreasing. So here in our original parabola, the graph is increasing from 0 to infinity, and the graph is decreasing from negative infinity to 0. So what this tells us is that in our new graph, wherever the original graph was decreasing, in our case from negative infinity to 0, we were going to have to draw it underneath the x-axis. And the opposite is true when it is increasing. We need to draw it above the x-axis. So we got that down in the graph here that's shown. And the critical thing is to graph now, but again, the graph is an approximate, it doesn't have to be exact. So keep in mind of a reference graph, again, such as x squared, you would get, let's see, x cubed by 3. The graph would be somewhat like this, so we're around the approximate range. And so the first statement, again, is the most key statement when you're looking at graphs. Say if this was your original graph, then it was increasing through the whole thing, so your whole graph would be above 0. So it's something like that.